And that's the two easier parts of the question done. In the next three parts, this question is going to pull together a number of different wave topics around this setup. So now we really have to engage with what's going on. So we've got two microwave transmitters and they are emitting coherent microwaves. So we have two coherent waves in this gap. The two waves are overlapping and they're going to superpose. And we know that means that we will get an interference pattern along this line here. So that's a fixed pattern of maxima and minima along this line parallel to the wave sources. We've got microwaves in this situation, so we don't have a screen or anything like that, we just have a detector and we move the detector along this line and it will detect the interference pattern formed. And we're told that the microwave detector is placed at O to start with. Okay, so now the next part of the question asks us, explain why the amplitude of the detected signal changes when the detector is moved in the direction OP. So that's where our detector is to start with, and it's going to be moved in the direction O to P, so that's that way. Okay, well we know this one, so this is, what that means is we're moving through the interference pattern. So for 2 marks we're going to say that as we move the detector, we're going to detect a series of maxima and minima, maximum and minimum signals. That gets us the first mark. And then we say because we get a maximum every time the two waves arrive in phase, and we get a minimum every time the two waves arrive exactly out of phase, and that the phase difference is changing as we move along this line. And the next part of the question, we are now calculating the distance between adjacent maximum and minimum signals. Now, the formula that will tell us the distance between two maxima is the double slits formula. So let's do that first. A, remember, is the slit separation, and so in this situation it's the distance between the two wave emitters. Capital D is the slit to screen separation, so in this situation that's the distance from the wave emitters to the line that you're moving the detector along. I think it's always helpful to think about the light situation and then sort of translate it into the microwave situation. So we can think of this as the slits and this as the screen, but obviously that's not exactly what we've got. Okay, and then we worked out the wavelength down there, and putting the numbers in, that tells us that the distance from one maximum to the next maximum is 0.60 meters, and then we just need to half that to get the distance from a maximum to a minimum signal.